So yeah, I'm Alex Turner, PM on the mixed reality developer platform at Microsoft. This is Oliver, also Yin Lee, so principal lead SDE, specifically on the Openxr team. We've worked together now at this point for like 4 years, 5 years now, on bringing Openxr to mixed reality devices, but also helping advance the state of the art for Openxr just in the industry and helping it grow from kind of its core of virtual reality devices out to all the full fidelity of what you can do on AR devices like HoloLens 2. And so kind of today, there's two halves of the presentation. I'm going to talk first about kind of like just in general what's going on with Openxr in the industry and what does it mean for Microsoft, where are we right now with the Openxr runtimes that we've got. And then Oliver is going to talk specifically about the work his team's been doing to integrate better and better into Unity to make sure we have a great experience for you as developers in Unity, where Openxr, as of a few weeks from now, when Unity 2019 goes out of support, will be the real primary way to go do virtual reality for our headsets and for augmented reality as well. So in terms of what Openxr is, right? It's an open, royalty-free API standard. It's the real deal. It's got all of these folks around the industry, all the folks who make a lot of the major headsets on the major platforms have all embraced it, right? And so for Microsoft, we're all in. You look at Meta, like for the devices, the Oculus devices, they've had, they're all in as this being the primary API. It doesn't mean our old APIs break or go away, but it does mean that like all the new investment, the new features, the new excitement comes into Openxr as the new API. And specifically what it is, right? Before you think of the before case of this diagram, where the industry was still figuring out what VR and AR APIs were, right? Everybody had their own proprietary API. We're all solving similar problems. We're trying to get pixels into the headset, do predictive head tracking, track spatial input from controllers or from hands. But we're all doing it in slightly different ways. But we kind of realized a bit ago that we actually could align here, that you didn't have to have every engine figure out how to talk to every headset, every API. We could actually align at the platform level, target one single API, improve that over time, invest in the quality of our implementation of that API, and run forward from there. So in terms of like today, right, we've come a long way since years ago when this kicked off. The Openxr runtimes, right? Microsoft, Meta, Valve for Steam VR, right? They had originally had the OpenVR APIs, and they've been a great participant from the very beginning. They had proposed the Openxr project originally with Kronos. Vario, HTC, Qualcomm, Collabora, and then there's also folks who don't just make whole headsets, but they're making parts. Devices that attach to headsets or components that participate with headsets. So like Ultraleap with hand tracking and Tobii with eye tracking. So a lot of these vendors that want to participate but don't necessarily want to have to do the whole thing, a lot of the architecture of Openxr with API layers and the way things can compose can start to let these folks participate, and we'll see a little bit more of that. And then also engines, right? Like Unity and Unreal were early participants in the Openxr working group, making sure this isn't just something for all of us as runtime vendors like Microsoft, right? That this is actually great for the industry, for the folks who are building on top of the API. As well as the kind of WebXR specification, right? So if you look back around the time Openxr was happening, the WebVR spec was coming about. But similarly, people were like, well, wait a minute, this is very similar to what you might need on the web to go do augmented reality, right? If you want to render head tracking, you have to have predictive head tracking. This is kind of similar. What does that look like if we try to do this together? And worked with the rest of the industry, helped reboot that as WebXR, and this is now shipping in all sorts of browsers, including on desktops in Chrome and in Edge. And all sorts of engines, not just engines that you can use to build your own stuff, private engines that are made by companies building games, so like Minecraft, Flight Simulator. We've worked closely with both of those teams to go make the support for VR great on top of Openxr, so it could support everyone's headsets. War Thunder, Phasmophobia, PlayVR, a lot of these folks, Blender, you get tools, not just games, but also tools that are starting to embrace Openxr, as well as obviously AltSpace VR from Microsoft. So kind of the history, like if you look back, and you've seen this slide before if you've been to Emmer Dev Days in the past, right? Like we started from 2017. We had the Openxr working group. It had kicked off. Microsoft joined a few months later in November. So kind of by the end of that year, a lot of the major runtime vendor or platform vendors were participating. Got the first demos going at SIGGRAPH when we had the 1.0 spec in 2019. We actually showed that off, and we did a lot of these demos, to show the real deal. You get one executable working on everybody's platform without going through any kind of intermediate compositor like SteamVR. Ended up in 2020 with the kind of first wave of runtimes where, hey, it's not just showing through and getting the core feature set, but people are bringing their own vendor extensions to it, right? So this is Microsoft bringing all the MSFT extensions that we need in order to get the full feature set of HoloLens 2. And then, by 2021, not just that the runtimes are there, but that the engines are in place, like they've got everything wired up, so you can use Unity, you can use Unreal to go build a full application that has all these capabilities. And then here we are today at Emmer Dev Days, showing off all the stuff we've been doing. Didn't want to stop there, and we really wanted to give you an update this year and all the stuff that's been going on over the last 12 months. So one of the things we have, if you roll back, the first runtime that we got going was the maybe obvious one that you would think of, the one that runs on the HoloLens when you have an app running there, or the one that runs on your PC when you're going out to a VR headset. And that's the one on the left. That's the kind of straightforward use case for Openxr. What we have now is the app remoting runtime as well. So Openxr can run, away from the headset. You can run in the cloud. You can run your app there, and we have partners who do that to run on big, beefy GPU instances that they rent in the cloud, or you might have one under your desk, but you're in a room and you want to wirelessly connect to that HoloLens so that you can render a lot more polygons than you might directly on the headset. So you can do that with holographic remoting. That used to be something you would do before Openxr. We've got that support now. There's a team that goes within Microsoft that builds that runtime as well. And so in terms of kind of their ecosystem, right, it's like there's tools that we build and there's tools that others build to target Openxr. So this used to be, if you've maybe seen this before, you might have seen it with the name Openxr Developer Tools. Right, this was the panel that we had for controlling Openxr on your PC. It was kind of initially the way that developers would opt into preview features when a lot of our extensions were still in that kind of preview phase. But people have started to use this a lot more. You get a lot of the flight sim community, for example, will pull this in and use it to customize things like render scale, whether you have the motion projection at the default or customized in different ways. And we've used this as a way to get features and settings and stuff out to people kind of before we bake them further into the system. And so, this has been great, for developers, for folks beyond developers. Developers also often have multiple headsets, right? You don't necessarily just have a mixed reality headset or an Oculus headset. You might have a bunch and they're all attached to your PC. And before you would use the Oculus API in your app and you talk to one, or you'd use the mixed reality API. With Openxr, you always have one current headset. And so as a developer, you end up having to switch. So Nick, who built StereoKit, also built Openxr Explorer. So if you're somebody who's testing out, especially in VR, a lot of different runtimes, and you want to switch, not just see here what's going on, but if you look in the upper left, actually toggle which runtime is current. Openxr Explorer is a great way to go and do that. So we talked a lot about the runtime vendors, like the people building the kind of base platform for Openxr, and kind of the reason for Openxr was to cut right to the chase, to connect your app directly to that platform without having to go through an intermediate layer like SteamVR that could add overhead. But you're starting to see folks who are using the kind of architecture of Openxr to not just go directly to the headset, but also attach extra things like, in this case, the UltraLeap hand tracker. So you can see there in the upper right the video of attached to VR headset, having the UltraLeap device on the front, and actually doing hand tracking and surfacing that hand tracking data through the same extension that you would use for a HoloLens or for any other device that uses the EXT hand tracking extension in Openxr. And so your app doesn't have to care, hey, is this an UltraLeap hand tracker that I'm talking to, or any other hand tracker? It's able to just use that generic cross-vendor hand tracking extension and be in business. And then, similarly, when you go up to Unity, once we've wired that hand tracking extension into Unity, you're in business all the way up the stack, including up into Unity or Unreal or whatever engine you're using. So Microsoft had worked with UltraLeap to make sure this was great for Windows mixed reality headsets. But really, the point is that once you get going here, you're able to do that for every headset out there. So, another thing here that we've seen with API layers, you have hardware vendors, obviously, but there's also folks who want to go and explore and figure out, what what can I do? What do I wish the platform vendors would add? Like people out in the community who want to say, like, I wish Microsoft, I wish Valve, I wish Oculus would add this feature, because then it could improve clarity. It could use this new feature of GPUs, things like super resolution and other things out there. And there's always going to be folks who want to explore in a different direction that maybe we'll get to right away, or anyone else will get to. Before, to deal with this, it was tricky. You'd have to do a lot of injection and kind of insert yourself attached to DLLs and do a lot of hackery. One other nice thing with Openxr API layers has been that folks like Matthew on the Openxr team at Microsoft has been able to, in his own time, right, not as a Microsoft project, like build out Openxr toolkit. And a lot of folks that kind of started with a lot of folks in the flight sim community who really wanted certain features that they had in SteamVR. They wanted them in Windows Mixed Reality, or they wanted to do them differently in a way that SteamVR didn't support. And so being able to kind of really explore here, interject in and intercept those calls, but in a very efficient way that's actually fully supported by the Openxr loader. And we've been able to really push through with Openxr Toolkit and other community projects to let folks explore and then figure out what they actually use and what's popular, and then you can start to go back to folks like the flight sim team and say, hey, it looks like everybody's using this. We really think you should add that to the app, because the community has actually gotten a chance to try it out. So this has been great as a way, and you can see if you go to the Flight Sim VR forum, quite a lot of activity. That's actually, if you sort by replies, the most active thread on the VR forum. So this is definitely something that's resonated with folks. Another really interesting project that's been coming out around in the past bit has been Open Composite. Right, so you have some apps like DCS, the flight simulator, that still use the OpenVR API, right? The one that would let you originally talk to SteamVR. And then ultimately, maybe it makes sense for folks to rebuild that backend on top of Openxr, but that takes time, right? But you still potentially don't want to go through all that overhead. So Open Composite's a project that's been out there where folks have figured out how to wire the OpenVR API directly to Openxr. So you're not going through kind of SteamVR as a compositor as an intermediate layer, you're just wiring those two together. And so we've worked as the mixed reality team with the folks working on Open Composite to make sure it works great with our runtimes. And now, like when you go to the DCS community, for example, they talk about how to use Open Composite to get the best performance, because you have a higher frame rate, you can run at a higher resolution, get more clarity for all the little knobs and buttons in the cockpit, and get a better experience. So like a lot of great stuff has been happening as the community's been able to really explore. So that's a lot of kind of what's going on out kind of around the periphery of the community. So like, what about for you if you want to dive in and get started here? So we're going to jump in and talk about Unity in a sec, but before that, in Unreal, Unreal 5, kind of big new kind of revamp of what's going on with Unreal. The mixed reality Openxr plugin is on track to be the recommended plugin there. And so we had kind of this legacy WinMR plugin. It was talking to our old APIs. That's being deprecated, and so Unreal is all in on Openxr. So you can get the plugin here, and don't worry about all the links. We're going to post to the deck for you later, so you can find all these links. But yeah, like watch the latest release notes. We're getting more features, object anchor support, latest version of remoting in there. So that's going forward. So I guess any questions about that stuff? And if not, once we're done with that, I can hand this off to Oliver. And Oliver, that was kind of a tour, but Oliver's going to go now and do a deep dive into what's been going on with Unity and all the great stuff we've been doing in the last 12 months to make Openxr better in Unity.
Have you projected me by everything that was in Windows? Or something for spatial anchors, persisting and transferring them.
Yeah, so like at this point, we've basically got everything. There are some things like that where there may be an API that we're pretty sure isn't the way that we would do something in the future. So there's like sometimes there's like a little bit of interop. Like that's kind of the one case where we've made sure, and we've had Openxr sample apps, and you can definitely write an Openxr app that does that. There might be, for those like few cases, like what we call like the perception interop, to go back and talk to the kind of native API, just because we're not sure that some of those APIs will translate to future devices. But like basically for everything else, I think at this point we have an API.
Yeah, what our goal is really like pave a way for all the developers who has existing content have a path to move forward with the new platform, right? Like that's how we're dealing with it. But some of those features, as Alex was saying, like some of the features was carried over from Holographic Runtime that was a long time ago that we didn't really like design a new set of API in Openxr to, like get the parity of them. But you can use the perception interop APIs to get back to the WinRT APIs to have those functionalities. It's a very small set of them, like batch. What do you call that?
The transfer.
Batch transfer APIs, and some of them.
That might be. Can you think of any others? That might be the only one left.
It could be. I cannot remember. Like a very small subset. I think we have been in the past year worked through most of the things to get parity right now.
And some of the gaps that Oliver talked about, like on the Unity side, so there were more gaps in Unity that had been closed. And so to my brain, I think that might be the only one. And it was an explicit decision just because we knew that there would be a different pattern going forward. Yeah. Awesome.
Yeah.
Okay. Oh, any other questions? I can hand it off to Oliver.
Yeah, I'm probably going to use this one. Yeah, it's fine. Yeah. So thanks, Alex. So I'm Oliver. I'm the dev lead of Openxr team in mixed reality. Our team's accountable for developing the Openxr APIs and the runtime for HoloLens 2 and the mixed reality headsets. Well, the other side of our team's work is actually to ensure the Openxr standard is integrated with middlewares well. And we have been working with middleware teams like Unity and Unreal team to ensure like our integration into these middlewares are in good quality. And today's my focus of my talk is really focusing on the latest progress of our Unity integration of the Openxr, especially focusing on the mixed reality Openxr plugin. So first, I would like to get a detailed breakdown of the Openxr plugins in the Unity. First, on the left-hand side, we had the Unity Openxr plugin, which is built by Unity XR team and is distributed by Unity. You can find it in the Unity's package manager called Openxr plugin, and it is integrating with most of the Openxr core features and cross-platform extensions. And these features works across all the XR devices from different vendors the same way. In fact, if you are building, for example, like a VR game on a Win32 platform, you most likely will just need this Unity Openxr plugin, and you can build your experiences with the VR game. And that game will likely work the same way on our VR mixed reality devices, the same way as you're on the Valve headsets or Quest PC platform. They're all supported by this Openxr plugin. Well, on the right-hand side is the mixed reality Openxr plugin. This is a plugin that we delivered from Microsoft by my team, and it is a extend to the Unity's Openxr plugin. This plugin is focusing on extending the functionalities for HoloLens 2 features using Microsoft extensions in Openxr. And so if you are building a wait, how do? Okay, here. So both of the Unity and the mixed reality Openxr plugin are extending the Unity engine through the XR SDK and XR subsystems, and basically it's a functionality extension to the Unity XR features. For majority of the applications, Unity applications who is writing C# scripts and using Unity's features, they're going to use the Unity API the same way across all the XR devices, such as AR Foundation or XR interaction APIs and stuff like that. But if you are building some special apps for HoloLens, you are likely to use some special features such as anchors for word scale tracking or plane finding or some holographic app remoting, these kind of features that is unique to HoloLens. Then you are likely need some new C# APIs that's specially designed for the mixed reality Openxr plugin. And these new APIs, C# APIs, are following Unity's convention, using Unity's types, and there is no more like pond-defined pond-defined Windows UWP anymore. You don't need to convert the matrix into some other convention from WinRT convention. WinRT convention to the Unity convention, that type thing anymore. These APIs will work the same way on Win32. And inside the Unity editor, you can debug them naturally. Okay, here. So now I'd like to do a deeper dive into the feature areas of these Openxr plugins and to look at different responsibilities of the Openxr plugins. On the top is the Unity's Openxr plugin. As we said, it's focusing on integrating the core Openxr features such as, app lifecycle, eventing, frame loop, stereo rendering, XR input for controllers or hand tracking. Like all these things are working the same way across all the XR devices. Where on the bottom, you can see the feature areas that the mixed reality Openxr plugin is focusing on. Majority of them are HoloLens 2 features like anchoring, articulated hand tracking, plane finding or meshes, or the holographic app remoting. And we recently published our API reference, C# API reference here that you can click the link offline and take a look at these new C# APIs, how to use them. So with these new APIs, as you can see, the Openxr plugin that is integrated with Unity 2020 and 2021 are providing a broadest feature set across all the HoloLens 2 use cases. I think we have shown this picture last year in the dev days around the same time, and this table has been progressed over the last year. In the first column, this is Unity 2019 with the legacy built-in XR plugins. This option is going to be it will no longer be supported by Unity later in this month. So in the second and third column, when you're using Unity 2019 or 2020 with the Windows XR plugin, which is the plugin that is using the WinRT APIs on HoloLens 2, this option is deprecated and it will be removed in the Unity 2021 product line. Well, if you compare the, by the way, even if it's deprecated in Unity 2020, this WinRT plugin, the Windows XR plugin, will continue to be supported because it's still in the LTS phase. It will be still supported for the next year until 2020 going out of the support. Well, if you compare the third and fourth column, you can see that Openxr plugin provides several better feature sets. Notably, it has a better AR foundation, integration for plane finding and mesh supporting, like ray casting. It also has a better XRI support, where the MRTK3 was built on top of XRI with Openxr plugin from the beginning when they're starting the MRTK effort. It also has a better support for linear color space asset pipeline that it will allow the application to have a better, more flexibility of their shaders and assets. So around a year ago during the Step Days, we announced our a preview, 0.9 preview of our MR Openxr plugin for HoloLens 2. At that time, we still have some very big key feature gaps. And during the past year, our team have been working closely with our partner teams and Unity team to fill in these gaps. Some of the notable ones, for example, the ARM32 support on HoloLens 2. There are still some customers on HoloLens 2 that using 32 bits of ARM architecture to move their content forward. We also started to support the listen mode for the app remoting scenario so that you can have your application in the listen mode, and when you boot up the player on your HoloLens, the connection get automatically connected without user intervention. We also started to support the QR and the scene understanding APIs through the Openxr remoting runtime so that you can have them working in the Unity editor when you are play to the HoloLens or you're doing it in the app remoting scenario. We are also working with the ASA team, Azure Spatial Anchor team and the Azure Remote Rendering team to make sure their Unity packages are compatible with Openxr when they're doing it in the latest Unity versions. So during this year, we are releasing quite a few different versions of our MR plugin, and every time when we release a new version, we publish our release notes on GitHub. And here is a link that you can check it out. One nice thing about a release notes on GitHub is that you can set up a notification that you can get an email notification whenever we publish a new version. And with these release notes, you can see what are the bugs that we have been fixing or the new features we added to the plugin so that you can decide whether you want to pick up this new version going forward. Here I would like to take a look of some of our big ticket work items that we have been focusing on in the recent past few months. First is this suspend resume bug that we have been we got from our customers' report on HoloLens 2, where the application on HoloLens 2 is showing 4 spinning dots when you, for example, put your HoloLens on the desk and it's getting sleep, and later on you put it up and you want to resume the app, you get this 4 spinning dots. This bug is involved in several weak spots in Unity, in our plugin, in our runtime. And a lot of them are related to race condition that when this bug shows up, it actually shows different things. I think a lot of customers told me they hit this, but they don't know what's going on. Sometimes the hologram get stuttered when you resume your app. Sometimes it's 4 spinning dots. Sometimes everything renders fine, but the anchor located in a different location that you don't know what's going on. I think all these things have been worked through, and we have released a sequence of fixes. I believe last week was the last one, last fix we have been shipping to the market. On the right-hand side, I captured the versions that contains all the fixes that you will need for the suspend resume scenario. It does require you to upgrade all the Unity, either 2020 or 2021 engine, or Openxr plugin from both Unity and Microsoft, and also the Openxr runtime that is already running on your HoloLens 2 lately. So another area of a focus for the team that is looking at is performance problems that customers are reporting. For example, some customers is using more than 200 anchors in their scenario that the performance is not up. And the fixes are already deployed, but it's pending for release of our latest Openxr runtime on HoloLens. And there are also hand tracking performance and URP rendering performance issues that has been reported, and we're working with partner teams to get them fixed. There are a few big feature gaps that we have been discovering in the past phase, where such as secure mode for the holographic app remoting, some customers are relying on, especially enterprise customers, and having the Azure Spatial Anchor working across the app remoting scenarios or in your editor remoting or speech commands. So we're working through these right now, and hopefully we can catch them up sooner than later. With all these issues, you might wonder, how do I choose a Unity version that will work for the scenarios I want for my project working on HoloLens 2? So we understand the friction here, and we're trying our best to improve in this area. So besides improving our own engineering quality of within our team and working with Unity closely on these issues, we're also trying to make any of these blocking issues to be as transparent to the developer community out there as possible. So first, a North Star for us is that we are generally supporting all the LTS stream of Unity releases and their verified plugins. So we commit to receive feedbacks and bug reports for HoloLens 2 and mixed reality devices, and we will work with our customers to find a solution and release them into the next version of our plugin. That said, we still sometimes hit some blocking issues on HoloLens 2. For example, as of today on this talk in the MR Dev Days, there is a blocking bug about the Urp Performance Regression in Unity 2021 product. And we would recommend you, if you are using Urp rendering pipeline, then we would recommend you to stay with Unity 2020 for now until the issue is fixed. Well, if you are not using Urp, then for any new project, we would recommend you to use the Unity 2021 LTS, which will get you closer to the latest technology delivered by Unity and us. But if you have an existing project that you are probably already using some other LTS stream of Unity, how do you choose your version? It really depends on you. We would recommend you to consult some of these release notes that we linked here, that you can take a look at the latest bug fixes and the added features to make a decision of what you are, whether you want to pick up the latest version and upgrade your project. For example, the suspend resume bug fix that we have a sequence of fixes released recently, it will be a good reason for you to upgrade your package and get to the latest versions. So we have been publishing a table like this in our documentation. It has a link that I won't say it's a real-time update, but we are trying our best to communicate with our developers about any blocking issues on HoloLens 2 whenever we can. And we're updating about the progress and actively communicating our mitigations. And as you can read through them earlier this week, we had a fix just getting released from the burst package that broke the HoloLens 2 IOCPP compile pipeline. And a new version, if you upgrade to the newer version, this bug will be gone. You will be okay. So you can either bookmark this, and it also a good place for you to notify us if you discover any significant bugs that it's worth to share with other developers for HoloLens 2. This is it has a place where you can report issues here as well. So if any issues showing up on this table, it means our team has been engaging with the partner teams to find a solution and to try to release a fix as soon as possible. So as you can see, we're making continuous improvement of our stability and performance of our plugin and our Openxr integration with Unity. So our plugin has a single stream of releases, right? Like it's a single plugin that will support both Unity 2020 and 2021 product, where when you are seeing a bug in Unity, it might be released to either 2020 or 2021, 2 different streams. But for our plugin, Openxr plugin, we have a single stream that will be released for both of them. That means that if you are picking up a new bug fix from us, it's likely you're going to pick up the latest version of our release to get the bug fix of our plugin. Therefore, we are very serious about our making breaking changes or avoiding to make breaking changes. So for any deprecated API that will still be available unless we're making our major change, major version change, which we have not done that before yet. So these deprecated APIs will give you a warning and tell you about the replacement, but the API will still be functioning for you to use. And we are also considering all the behavioral changes as serious as any API breaking changes, so that you will not, get surprises when you're picking up the new version. Also we are bumping up our minor versions whenever we introduce any new APIs, so that it's easy for you to configure your Unity project to do this pump define of a certain version, to do this, to easier for you to configure your workarounds if you need any. So our goal is really to remove the frictions for you to pick up the latest version of our Openxr plugin, so that you can watch our latest release notes on GitHub and get update to the latest version of our plugin whenever you need to do that for your project. And to upgrade, we recommend you to use the mixed reality feature tools. You probably have followed this instruction on our documentation to get this version update. And finally, there's a call to action. So on the left, there is an open source GitHub sample for our Unity Openxr sample project. It contains all the interesting scenarios that is special for HoloLens 2. It's a project that our team is using every day. It is a great place for us to communicate what is the expectation, what is the best practice of using HoloLens 2 with Openxr together. And it is also a GitHub repo where we receive issues that if you hit issues or want to start a conversation with developer team, with our developers in the team, this is a place for you to report. And I also captured some of the documentation and API reference links here for you to review offline. And with some of these useful links on the screen, I want to open the floor for questions.
So in one of the earlier slides, I mean, you started are at all the things go in with Openxr. All however, this standard VR environments, but we all the difference and part of this.
Yeah. Right.
Don't call you cannot do that, but
sure.
Are they playing in the same plane?
Yeah. So to repeat the question, it was basically like, we talk a lot about stuff that's common across vendors, a lot of interesting things, maybe more in the kind of desktop PC VR realm, where stuff is shared. Does that apply to the world of AR as much, like AR Core, AR Kit, folks like Google and Apple, and how does that apply there? Which is a great question, right? Because like if you do look at Openxr, there is broad support for headsets, and there's support across VR and AR and standalone, and also things attached to desktops. And one of the exceptions that does exist is the presence of like AirCore and AirKit, right? Like when you look to WebXR, right? Google does participate on the AirCore side in WebXR, but they haven't participated on the Openxr side.
You have one of the slides.
Yeah, so actually, if you maybe go forward to the grid, the grid slide. Yeah, so it's interesting because like the different layers of the stack, right? There's different opportunities to unify things, right? So Openxr is kind of great at the base layer in order to get all the headset vendors the same, so that it's efficient for us to build the Unity support, and so that when you use stuff like when any vendor is contributing fixes to Unity, that you benefit from that. But once you get into the Unity layer, there's more things that can be unified, right? And Unity itself has patterns like inside AR Foundation, you'll see things like AR Anchor Manager, AR Plane Manager, AR Raycast Manager. Those are APIs inside Unity that do unify across Openxr and all the places where Openxr provides anchors and planes and the different extensions there that do that, but also across other APIs that aren't Openxr, things like ARCore and ARKit. So when you're building your app in Unity, you may already, let's say your solution starts from the ARCore ARKit side. We find a lot of HoloLens 2 solutions will have some part that's maybe like a tablet, another part that's on the headset. And so before, you'd have to kind of write the plain code two different ways, because maybe you were using your AR plane manager for doing the ARKit side, then you'd have to use like spatial mapping APIs on HoloLens, and you'd have to kind of unify that yourself. So part of getting over to the Openxr plugin is we're participating in AR Plane Manager the same way that it works in ARCore. So if you write that code and you're able to find planes, you can use that code equivalently across both. And then a lot of the work we're doing kind of over the next year is to figure out how do we take that, and so when you start in that base, we can then start to do the extensions to that to say, hey, there's actually a lot of extra capabilities you have on HoloLens 2 that go beyond what you can get from AR Plane Manager. Let's make sure there's no cliff, that you start from Plane Manager and then you're able to go and do all the extra things, all the scene understanding stuff, classify the planes into different categories and stuff like that. Yeah. Thank you, Matthew. From the team and also from building out a lot of the awesome Openxr toolkit stuff. So figuring out how do we actually report issues? Like if you're in the community, you're hitting a thing that's going wrong, right? Like, hey, do you go to Slack or do you go to GitHub or where do you go? I think if you, and we were talking a bit about this yesterday, right? If you actually have like a concrete issue, like, hey, I'm doing this, I'm using the Unity plugin, and I'm hitting an issue. We might actually rename the repo, but for now, the samples repo is kind of the primary GitHub repo where we put the release notes and also we publish samples, but also there's the issues list on GitHub in that repo. And I think for now, for actually kind of like issue tracking publicly, that's the best place to report things, issues you're finding with Unity. If you just want to kind of talk about something like, wait a minute, what's the best way to do this? Or I thought this would work, but now I'm confused, right? You can go to the other places we have, like kind of the Holo Developers Slack is a great place. So I would say kind of for issues, go to GitHub, go to that samples GitHub, and then otherwise kind of Holo Developers Slack and places like that are a pretty good place.
Yeah, I think that GitHub for our samples, likely we're going to rename it with our plugin as a name so that they know it's related. Where that will be a great place if you're a Unity developer and you're hitting some issues about developing your application. That's a great place to report issues. I think it really depends on where the issue is coming from. I think for the person who is reporting the issue, like for example, if they are a user who is using who is trying to experience some new features of a fly sim, right? Like they probably gonna go to like either Reddit or like some other places to report, like flight sim forum to report their issues. And if you're like Unreal developer, you will report it from some Unreal channel, not through like Unity channel. Like I think we're trying our best to catch up all the channels to meet our developers or customers as much as possible. And certainly we're a small team. We don't have the bandwidth to really read everywhere. So, but make it loud so that we can get you is the best way to reach us, I think.
Yeah, and I think kind of among those two sample repos, right, there's like the Unity one, and then you can see there's also the C++ one that's just kind of OpenXR-mixed reality. So if you're not using Unity, if you're talking to the APIs directly and you're hitting weird things in our runtime, then that would be a great place for that.
Are they part of the plugin that you folks provide? Opposed to the general Openxr plugin and
yeah.
And then the third one is you mentioned those blocking issues. How good is Unity in responding to those blocking issues? So what is the longest blocking issue that keeps staying open? Because it's important for us developers. In some cases, we do pivot.
So let me try to repeat the question. Like question number one for this Unity, for the, I think 1, 2, 3, 4, the fourth row, the Unity OpenXR sample repo for HoloLens 2. This repo we designed specifically for HoloLens 2 scenarios. It does use all the common Unity XR APIs for just a general like XR app. You will need like app manifest. You will need the best practice to really being deployed to a U2P app on HoloLens, and you will need the best practice of rendering and inputs. All these things are common things that every XR app will do, and this repo also include that. But we do actually highlight some of the scenarios for HoloLens 2 specifically. I think that's sort of our accountability to educate from our team from Mixed Reality, because the other features from Unity, I bet there are many other tutorials and samples out there for how to develop like a XR experience. But for the HoloLens 2, it's there are special things that we need to highlight. That's where this repo is special about. And second, you were asking whether this thing has a dependency to MRTK. First, it does, but second, we actually deliberately only use MRTK for convenience of UI, that you can switch things like a button click, those type of things. For most of the features that we are showing off in these samples, like how to do anchoring, how to do like a store or plane finding, all these things, we're actually trying to show as raw as possible about our API usages. The MRTK there is purely just for us to conveniently build UIs there. Like we deliberately coding our samples in that way. And for your third question, I forgot. Oh yeah, about the turnaround time for blocking issues. It depends on I will say it depends, right? Like we are on our side, we're trying our best to get our partner teams on trying to find the corresponding person there. But yes, sometimes some of the bugs actually staying on that table for a long time, but some of them are actually getting quite quickly turnaround time and get fixed quickly. I think going forward, with this page, I think we will give like our partner teams and our customers a better visibility about what is going on. At least you will have an idea of what is going on at any moment instead of hiding them.
Yeah, and I think you were asking about kind of the one that maybe has been there the longest, like I think maybe the URP issue in Unity 2021 with like the perf regression has been the one that I think we've maybe been tracking for the longest. It just requires some of the deeper fixes into the Unity engine just by the nature of affecting rendering. But I think definitely it's also something that for a lot of apps you can work around by not using URP. URP tends to be more important if you're using, let's say, Azure Remote Rendering or something like that. So what I would encourage is if you find yourself in your application that you're building blocked by any of those blocking issues, definitely like file contact us on Slack, file issues, and I think that can help us, just kind of motivate, across Microsoft and across Unity the impact of getting this stuff fixed even quicker. Yeah.
It does. Well, QR codes is a. I'm sorry. Repeat the question. Whether the QR code works with Openxr in Unity, right? First, yes. The answer is yes. We currently don't have a Openxr C API, like a part of the standard for QR codes specifically. It is done through several of the interop APIs, specifically the spatial graph interop APIs. And we had a GitHub samples for that works with Unity QR codes with Openxr plugin. We are in the progress. This is my fault. I have not merged that sample into this sample repo yet. Right? One part of the reason is that it involves some of the complex, the WinRT interop APIs that will require that the project to set up the Unity project a little bit differently. So I haven't merged them into this sample yet, but I can actually in the future add a link. At least you will have a GitHub sample that you can build and run with the latest Unity version and Openxr plugins.
Yeah.
Definitely. That's one of the feedback we heard. We also recently validated through the. I don't know if you have noticed there is a remoting holographic remoting Openxr runtime. It recently have a 2.8 release that supports QR through remoting as well, and as the scene understanding, like plane findings and stuff like that together, so that you can use them, use the same AR foundations and the QR code samples in the editor remoting to test on HoloLens through the app remoting.
Awesome. So yeah, I think that's our time today. So yes, thank you all for coming, and yeah, definitely catch us afterwards or on Slack or in GitHub if you have more questions. Thank you.